In section 6.1, we're going to consider greatest common factor and factor by grouping. First of all, if you notice, if we multiply 3 by 4, we get 12. Well, it turns out that the 3 and the 4 are called factors, things that we multiply together to get the result, in this case 12. Now, factoring is related to the distributive property. Remember, when we went something like 2x times the quantity 3x minus 5y, what we did is we took that 2x and applied it to the 3x and the negative 5y. So in other words, we multiplied 2x by 3x, and then we multiplied that 2x by the negative 5y. Then we simplified 2x times 3x, 6x squared, and then 2x times negative 5y is negative 10xy. Now notice what we did there. We started with this multiplication of two polynomials and got down to this result using the distributive property. Well, in this section, what we're going to be doing is we're going to be starting with this result, with the simplified result, and we want to go back to what are the polynomials that are multiplied together to get that result. That's called factoring. Sometimes that's called reverse distributive property. It's really not, because the distributive property works both ways. But a lot of times people think of factoring as sort of the reverse distributive property. And the technique involves recognizing. We recognize that we have this simplified expression and that we can find common factors. In this case, the common factors were x and 2. Once we factored out that 2 and x, why, then we were able to see that the original result was the multiplication of these two. Now, I'm going to do an example here. Let's clear our board. Do an example, and we want to find the greatest common factor, say, of negative 12b cubed plus 10b squared minus 2b. Again, what we want to do is we want to recognize the fact that we do have a polynomial expression, which we do. We have 3 terms, and each term has factors, that is, things that are multiplied together to get that term. And some of the factors that each of these terms have in common, well, I see a plus or minus 2, I see a b. But now what we want to do is isolate out what's called the greatest common factor, GCF. That is, we take the greatest combination of all of these common factors. And in this particular case, it's plus or minus 2b. So I'm going to rewrite this original expression, and I'm going to use the negative 2 side of this thing instead of the positive 2. So the original expression equals, well, negative 2b. And let's see, what's left over in that first term after we pull out negative 2b? Well, turns out 6b squared. Okay, the second term, if I pull out the negative 2b, I'm going to be left with negative 5b. Can you see it? If you pull out negative 2b from 10b squared, you're left with negative 5b. And then finally, minus 2b, I'm going to be left over with just 1. And that's okay to have a 1 in there. That means that the entire term was the greatest common factor. Okay, now I'm going to apply my distributive property in reverse, if you like. Okay, so I have a negative 2b, and a negative 2b. Each one, here's this term, and this term. I'm going to pull out those terms, and I'm going to rewrite this so that I have my negative 2b out front. I'm going to take my 6b squared, my negative 5b, and my 1. And that's the factorization of this original expression. We found the greatest common factor, factored it out, put it out front, and then wrote down the remaining polynomial.